Good day everyone, this is Achele GEVERO III and I have been assigned to report 5 topics, namely basic rules of derivatives, chain rule, implicit functions, derivatives of logarithmic and exponential functions, and derivatives of hyperbolic and inverse hyperbolic functions. Let us start. There are 5 basic rules of derivatives. The first rule is the derivative of a constant. Let us assume that u and v are the function of x. The derivative of c constant is equal to 0. So if y is equals to c, then the derivative of y over dx is equals to 0. The second rule of derivative is the derivative of a sum. The derivative of a sum of two functions is equal to the sum of their derivatives. So let us assume that u and v are functions. Y is equals to u plus v, and the derivative is dy over dx is equals to d times u over dx plus d times v over dx. So let me give you an example. Y is equals to 4x plus 3. dy over dx is equals to d times 4x over dx plus d times 3 over dx. We just copy the derivative of the sum rule. Next, dy over dx is equals to 4 times d times x over dx plus d times 3 over dx. Then we apply the substitution. Dy over dx is equals to 4 times 1, and then the derivative of a constant, which is 3, and the derivative of 3 is 0, so 4 times 1 plus 0, and the answer is dy over dx is equals to 4. The next rule is the derivative of a product. The derivative of a product of two functions is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So let us put it this way. Y is equals to u times v. So dy over dx is equals to u d times v over dx plus v times d times u over dx, or simply dy over dx is equals to u dv plus v du. Let me give you an example. Y is equals to 2x squared minus 4 in a parenthesis times 3x minus 1. So the derivative goes like this. Dy over dx is equals to 2x squared minus 4 times the derivative of 3x minus 1 over dx plus 3x minus 1 times the derivative of 2x squared minus 4 over dx. So next, we find the derivative of the said polynomials. So dy over dx is equals to 2x squared minus 4 times the derivative of 3x minus 1, which is equals to 3, plus 3x minus 1 times the derivative of 2x squared minus 4 is equals to 4x. So dy plus over dx is equals to, you multiply 2x squared minus 4 times 3, which is equals to 6x squared minus 12. Then you add it by the product of 3x minus 1 times 4x. So 12x squared minus 4x. So the sum is dy over dx is equals to 18x squared minus 4x minus 12. The next rule of derivative is the derivative of a quotient. The derivative of a quotient of two functions is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So y is equals to u over v. So the derivative goes like this: dy over dx is equals to v times the derivative of u over dx minus u times the derivative of v over dx all over v squared. So in a simple manner, we put it like this: dy over dx is equals to v du minus u dv all over v squared. I have an example. So this is just a simple example. Y is equals to 3x over 10. So the derivative is dy over dx is equals to 10 times the derivative of 3x over dx minus 3x times the derivative of 10 over dx all over 10 squared. Dy over dx is equals to 10 times the derivative of 3x, which is 3, minus 3x times the derivative of 10, which is 0, all over 100, which is the product of squaring 10. So dy over dx is equals to 30 over 100, or if we simplify it, dy over dx is equals to 3 over 10. The fifth basic rule of derivative is the power rule. The derivative of y is equals to x to the power of n, where n is the exponent. So dy over dx is equals to n times x raised to the power of n minus 1. But if n, or the exponent, is equals to 1, then the derivative is dy over dx is equals to 1. I have a basic example for this. Y is equals to 4x to the power of 5. So the derivative is dy over dx is equals to 4 times 5x to the power of 5 minus 1. Dy over dx is equals to 4 times 5x to the power of 4. So 4 times 5 is equals to dy over dx is equals to 20x to the power of 4. So let us apply some of the topics that we have, or the rules that we have discussed earlier with this problem. Y is equals to 2x minus 1 over 2x plus 1. So dy over dx is equals to the quantity of 2x plus 1 times the derivative of the quantity of 2x minus 1 over dx minus the quantity of 2x minus 1 times the derivative of 2x plus 1 over dx all over 2x plus 1 squared. So this rule includes the quotient rule of derivative. Dy over dx is equals to 2x plus 1 times the derivative of 2x minus 1, which is 2 minus 0, minus 2x minus 1 times 2 plus 0, which was the derivative of 2x plus 1. So we used their simple power rule and the constant rule. Dy over dx is equals to 2x plus 1 times 2 minus the quantity of 2x minus 1 times 2 all over 2x plus 1 squared. Dy over dx is equals to 4x plus 2 we basically multiplied the given earlier minus quantity of 4x minus 2 over 2x, or the quantity of 2x plus 1 squared. Dy over dx is now equal to 4x plus 2, and we multiply the subtraction sign with 4x minus 2, which now becomes negative 4x plus 2 all over 4x squared plus 4x plus 1. Now dy over dx is equals to 4 over 4x squared plus 4x plus 1. The next topic we are about to discuss is the chain rule. So the chain rule is applied every time a function can be used as a composition of more than one function. This means that it uses the general power rule, which is y is equals to u raised to the power of n. However, u is a binomial or a multinomial function of x, and n is the power or exponent. So we put it simply as y prime is equals to n times u raised to the power of n minus 1 times du over dx, or the derivative of u over dx. Here is the problem that I have formulated for the chain rule. So y is equals to the quantity of 4x plus 1 squared times the quantity of 3x minus 1 squared. Dy over dx is equals to the quantity of 4x plus 1 squared times the derivative of the quantity of 3x minus 1 squared over dx plus the quantity of 3x minus 1 squared times the derivative of the quantity of 4x plus 1 squared over dx. So dy over dx is now 4x plus 1 squared times 2 times the quantity of 3x minus 1 times d over dx times 3x minus 1. So basically, we used the chain rule here. So the power rule, which is the exponent 2, has been put down as a factor, and now 3x minus 1 has been derived, plus 3x minus 1 squared times 2 times the quantity of 4x plus 1 times the derivative of 4x plus 1. Dy over dx is 4x plus 1 squared times 2 times the quantity of 3x minus 1 times 3 plus 3x minus 1 squared plus 2 times the quantity of 4 plus 1 times 4. 4 plus 1 squared times the quantity of 6 times 3x minus 1, because 2 and 3 are multiplied, plus 3x plus 1 squared times the quantity of 8 times 8 times the quantity of 4x plus 1, because 2 and 4 have been multiplied. Now it has become 6 times 4x plus 1 squared times 3x minus 1 plus 8 times the quantity of 3x minus 1 squared times the quantity of 4x plus 1. So we factor out and come up with the quantity of 4x plus 1 times 3x minus 1 times 6 times the quantity of 3x minus 1 plus 8 times the quantity of 4x plus 1. Dy over dx is equals to 4x plus 1 times 3x minus 1 times the quantity of 18x minus 6 plus 32x plus 8. This has become now dy over dx equals 4x plus 1, times the quantity of 3x minus 1 times the quantity of 4x plus 2 as our final answer. The next topic would be the implicit function. Implicit functions is a relation of x and y that will be written as f of x and y is equals to 0, or a function of 2 or more than 2 variables or arguments. So I have here a problem as an example. 3x squared plus 2y squared is equals to a squared, where a is a constant. So the derivative of 3x squared plus the derivative of 2y squared is equals to the derivative of a squared. So derivative of 3x squared now becomes 3 times 2x because of the power rule, same as 2y squared. It now becomes 2 times 2y y prime is equals to 0 because a squared is only a constant. Now it has become 6x plus 4y y prime is equals to 0. Now we transpose the 6 from 4y y prime, and the equation becomes 4y y prime is equals to negative 6x. Then we divide both sides by 4y to leave y prime in the left of the equation. So y prime now becomes 6x, negative 6x over 4y. And the final answer would be y prime is equals to negative 3x over 4y. So the next topic would be the derivative of logarithmic and exponential function. Logarithm to the base b log bx, which was defined in terms of the exponential functions f of y is equals to b to the power of y by the relation y is equals to log bx if and only if x is equals to by, where x and b is not equal to 0 and b is not equal to 1. So to find the derivative of other logarithmic functions, you must use the change of base of formula. Log a of x is equal to the inverse of x over inverse of a. With this, you can derive logarithmic functions with any base. For example, if f of x is equals to log 3x, then f of x is equals to the inverse of x over the inverse of 3. So I have an example here. Y is equals to x to the power of 3 times e to the power of 2x. dy over dx is equals to x to the power of 3 times the derivative of e raised to 2x plus e raised to 2x times the derivative of x to the power of 3. This is applying the product rule of derivative. dy over dx is equals to x to the power of 3 times e raised to the power of 2x times the derivative of 2x plus e raised to 2x times 3x. This is chain rule. dy over dx is equals now to 2x raised to 3 times times e raised to 2x plus 3x times e raised to 3x. dy over dx is now x is equals is now x times e raised to 2x times the quantity of 2x plus 3. That would be the final answer. We are on to the last topic, which is the derivatives of inverse hyperbolic functions. So first off, we need to memorize 6 different formulas, namely the formula of inverse hyperbolic sine, inverse hyperbolic cosine, inverse hyperbolic tangent, inverse hyperbolic cotangent, inverse hyperbolic secant, and inverse hyperbolic cosecant. I have here an example. The problem says, find y prime if y is equals to arc x cos x minus the square root of x squared minus 1. So x arc cos x is a product of multiplying x and arc cos x. So we derive this by using product rule, and in the square root of x squared minus 1, we can have its exponential form as x squared minus 1 raised to the power of 1/2. So dy over dx is equals to the derivative of x arc cos x minus the derivative of x squared minus 1 raised to 1/2. dy over dx is equals to x over x times 1 over the square root of x squared minus 1 times 1 plus arc cos x times 1 minus 1/2 times the quantity of x squared minus 1 times raised to 1/2 minus 1 times 2x. So in this situation, we have to cancel out 2 and 1/2 and 2 and 2x. dy over dx is equals to x over the square root of x squared minus 1 plus arc cos x minus the quantity of x squared minus 1 raised to negative 1/2 times x, which will become dy over dx is equals to x over the square root of x squared minus 1 plus arc cos x minus x over the square root of x squared minus 1. And we cancel out both x positive and negative x over the square root of x squared minus 1, which will leave us to the answer of dy over dx is equals to arc cos x